Okay, today we'll be going over the categorical cross entropy loss function, which goes with softmax function. We'll be using it for the MNIST dataset, and yeah, it's for obviously categories. Though we'll be using it for the categories of digits 0 through 9. And the way we'll have our true values structured to work with this will be, it's called one-hot encoding. I'm sure many of you know about. But basically, if you have a, let's say 2 is your desired number. Let's just say it's out of 1, 2, 3, 4, 5 categories. So 0 through 4. So 0, 1, 2. It'd be like that. Rather than having a 1 or a 3 as your value. So yeah, that's the way the data will be set up. I'm not coding out this. I'm just going to go through it as, and it's going to be on the screen here. So yeah, got the constructor, taken number of classes, number of samples. The forward pass will take the Y predictions that come out of the softmax layer, as well as those one-hot encoded true Y values. The backward will take the says D values, but just like sigmoid or just like the binary cross entropy, this will really be the softmax. This will be the softmax output, like the binary cross entropy was taking the sigmoid output, as well as the Y true values. Derivative of the inputs, we'll need that. Negative log likelihood for the losses during the forward pass. I'm gonna clip the Y predictions again for stability, and a correct confidences matrix. I'll show that where that comes in the forward pass. But yeah, so then we do the constructor, allocate all of the matrices we'll need here. So you can just copy that. I will end up having a GitHub for all this stuff, so you can, if you're just wanting to copy this code as well, you can do that. Otherwise, double check everything. And then forward pass, do a for loop, 2 for loops going through the rows of the predictions and the columns of the predictions. The way I did it is having a sum for each row, and then you go through the column, you create the clipped predictions, and then the sum will add up those clipped predictions multiplied with the true value, which really means that it's only going to be one value, because all the Y trues will be 0 except for one spot. So if your prediction was, if the correct prediction is 3, so you'll have 0, 1, 2, 3. So if the correct prediction is 3, in this for loop, you're going to have 0 times some value, 0 times some value, another 0 times some value, and then the y true here will be 1 for the 3 value, and that'll be multiplied with whatever the output of the softmax at the third, or at the 3 value, which let's say it's 0.02, then everything else will be 0 and sum will just be 0.02. You could do it a different way using an if statement, going through the true values, and if true is 1, then make sum equal that prediction value. Or I guess in other words, you could just make that correct confidence is equal to the predicted value and skip over using the sum altogether. But sometimes if statement's actually slower. Either way, you'll be going through the for loop, so I think this is probably a little faster. And then with those correct confidences, you'll use that to get the negative log likelihood, which is basically gonna say what your loss is. And you'll take the negative log of correct confidence to get that negative log likelihood, obviously. And then we'll go to the backward pass. Takes the output of the softmax. We want to get a couple ways. You don't need this exactly, but you can do the samples, which is the number of rows, which just goes right here. You could just make that dvalues.rows converted to a float. But you go through the derivative of the inputs through the rows, through the columns, and that get that gradient is equal to negative of the y true divided by the output of the softmax, and divide that by samples, number of rows. And that's all there is to categorical cross entropy. Next we'll be making this new image neural network, and we'll be putting everything in there. I am skipping over the gathering of the image data unless somebody wants to put in the comments that they want it. I'll put that in the GitHub. I've just put it here, these functions here, as another file, including the neural network, or the nn.cpp file, which has all this. And so that way, include it in the image gathering, so that way we can just include that. You don't have to do it that way. You can put them in separately, but the image gathering does need, let's see, I believe it does require, yeah, it returns a matrix, so you'll need the matrix file in here at least. I don't remember exactly where I got the MNIST dataset, but you can just Google MNIST, download it. Once again, if anyone needs me to go back and find out how I did it, just let me know. But yeah, you can just download it. And those are the file names. Here's the functions for reading the images from the file, reading the labels from the file. We'll get a random vector, which pulls out every time through the for loop is going to pull out certain images and labels we'll use for training, randomly, of course. Randomize image and labels. But yeah, and then next video I will go through the setup of creating that neural network that we're going to train. At this point, you could probably do it yourself. It'll be very much like our previous one here. Let's see. So you'll have the data, which you'll get through here. Have all the different parameters you're going to need there. And then, let's see, so you don't need that. Then you'll set the different layers. And then all this, instead of sigmoid and binary cross entropy, you'll be using the softmax and categorical cross entropy, which we've already created in the NN file. Go through, do the forward. Probably don't want to output these values. Instead, you'd probably want to just output the losses at each check iteration, and then do the backward, get the gradients, update the parameters. I believe, let's see how many. Still gonna do just three layers, and I am doing this with dense layers for now. For this one, we'll be doing dense layers. I'll go over doing a convolutional neural net in future videos in a whole different playlist probably. But yeah, that's it.